Hello everyone, welcome back to my channel. Today we'll learn about Generative Adversarial Network, that is GANs. So let's dive in. Generative Adversarial Networks (GANs) are a class of deep learning architecture used to generate realistic data by learning patterns from an existing datasets. GANs are introduced by Ian Goodfellow in 2014. GANs are considered as one of the most exciting breakthroughs in AI as they have transformed how computers generate high-quality images, videos, and realistic data. GAN train two different networks to compete against each other. One network is Generator. This is to generate new data, while the other is Discriminator. This is to evaluate whether the generated data output belongs to the original dataset or not. Architecture of GANs. In order to understand GANs, we must first understand the two models, that is Generator and Discriminator, which works together to create realistic data. Now let's understand what is the generator. The generator is a convolutional neural network. The generator takes random noise as an input. The goal of generator is to artificially generate fake data like image or text that resemble real data. Its objective is to fool the discriminator and produce samples that the discriminator classifies as real. Next we have is discriminator. The discriminator is a deconvolutional neural network. The discriminator takes real data and fake data as an input. The objective of discriminator is to identify between the real data and artificially generated data. This model learns to improve by continuous training and updating its parameter to detect fake data more accurately. How GAN works? So this figure indicates the structure of GAN. Now let's see how the training process in GAN happens. Now let's learn how the GAN works actually. The training process. First we have the initialize. The generator is given random noise as an input and the discriminator is given real or the ground truth data and fake image as the input. Next is the training the discriminator. The discriminator has both real and fake data as an input. The discriminator calculates the output probability, a value between 0 and 1, where 1 indicates the real data and 0 indicates the fake data from the generator, and it updates the weight to distinguish properly. Now is the process of training the generator. The first is generate fake data and then it is passed to the discriminator. If the discriminator is fooled, then generator improves. So with many repetitions, generator improves its output. So this is iteration process. Both the networks, generator and discriminator, are trained simultaneously in a loop. The generator improves at producing realistic data and the discriminator improves at telling the real from fake. Therefore, this process of training continuously until the discriminator can no longer tell real from fake. That means the generator has become highly accurate. Types of GANs. There are several types of GAN models depending on how the generator and discriminator interact with each other. All GANs are developed to address a specific task. These are some important ones. Now let me explain each one. Conditional GAN or CGAN adds an additional conditional parameter to control over output generation by using labels. Therefore, the input here is noise and label. The objective here is to allow the model to produce certain type of output rather than generating random output. The example is CGAN can generate a specific object like a dog or the cat according to the label provided. Vanilla GAN. These are basic model of GANs. It consists of generator and discriminator involved in typical adversarial game. It needs to be more enhanced for handling real-world applications. Deep convolutional GAN, that is DCGAN. This uses a deep convolutional neural network for better image generation. They are popular for generating high resolution and realistic images. CycleGAN. This type of GANs are used to learn how to transform images between various styles by using unpaired datasets. For example, a model can be taught how to alter an image from a horse to a zebra or vice versa. StyleGAN. It is developed by NVIDIA researcher in 2018 and it produces high quality and extremely realistic photos of faces, artwork and more. They are trained by using a dataset of images of same object. Super Resolution GAN. It is designed to upscale low resolution images to high resolution images. This model improves image resolution by adding finer details to make more realistic and sharper. Use cases of GANs. GANs are widely used in various industries where data generation or data transformation is needed. Some of examples are image generation, image-to-image translation, object detection, medical imaging, image super resolution, data augmentation, game design, text-to-image generation. So these are the use cases of GANs. Okay, that's all for Generative Adversarial Networks, GANs. We get to know that GANs are remarkable innovation in deep learning. It has revolutionized AI, research and various applications. That is all for today's episode. If you liked the video, do not forget to like, share and subscribe to my channel. Thank you for watching.